Alright, the name of this short video clip is called Given Set Conditions for Constructing a Triangle and What It Tells Us. There's a couple of definitions to start with. A triangle is a three-sided figure. It's composed of three line segments which intersect at their endpoints, and it has three interior angles. The sums of their measures is always 180 degrees. Now, similar triangles, they have congruent or equal angles, but the triangles are not the same, meaning that the length of their sides are proportional. So side 1A is a proportional length to side 2A, side 1B is a proportional length to side 2B, etc. Now, congruent triangles have equal angles and equal side lengths. There are some special types of triangles you need to know. A right triangle is a triangle that has one right angle. That right angle is 90 degrees and is depicted by this symbol right here, a little square in the corner. An isosceles triangle is a triangle that has two congruent sides and two congruent angles. So as you can see in this picture here, two of the sides are congruent. That means they're equal to each other in length, and two of the angles are also congruent. In an equilateral triangle, a triangle that has three congruent sides, and it also has three congruent angles, each of which are 60 degrees. So right here you see a depiction of an equilateral triangle. Equilateral, so it's equal laterally. Equal sides all around, equal angles all around. A scalene triangle is a triangle with no congruent sides or angles. So none of these angles are equal to each other. They're all different. And each one of these sides is a different length. That's a scalene triangle. Alright, now suppose you were given just the angles. So you're given angles of measures 30 degrees, 45 degrees, and 65 degrees, and you're asked to construct a triangle. Can you do it? How could you determine if this is a viable triangle, one that you can be constructed given these conditions? Well, when given the condition of specifying all three angles, all you need to do is add the measures together. If the total is not equal to 180 degrees, then it's not a viable triangle. Can't be done. 30 plus 45 plus 65, is that equal to 180? No, it's only equal to 140, so no, you cannot create a triangle with those three measures for interior angles. Let's look at this example. Supposing you're given the angles that are measured 30 degrees, 120 degrees, and 30 degrees, and you're asked to construct a triangle. Can you do it? Well, does the sum of the measures of the interior angles equal 180 degrees? Sure does. 30 plus 120 plus 30, 30 plus 30 is 60, plus 120 is 180. We notice that two of the angles are equal. This is an isosceles triangle that you can construct. So we could construct a triangle given these conditions, and only one such triangle could be constructed since an isosceles triangle has two sides of equal length. Here's another example to consider. You're given sides measuring 3 inches, 6 inches, and 15 inches and asked if you can construct a triangle with those dimensions. How could you determine if it's a viable triangle, one that can be constructed given those conditions? Well, here's a theorem for you. The triangle inequality theorem states that the sum of two sides of a triangle must be greater than the length of the third side. So I look at 3 plus 6, it's greater than 15. No, it's not. 9 is not greater than 15. Nope, that's a no. 3 plus 15 greater than 6? Well, that's definitely true. 6 plus 15 greater than 3, and that's true. But because one of these pieces is not true, then you do not have a triangle. Can't construct a triangle based on those dimensions. And here's another example to consider. You have sides measuring 6 inches, 9 inches, and 15 inches. How could you determine if this is a viable triangle, one that can be constructed given these conditions? Use the same theorem. Is 6 plus 15 greater than 9? Well, 9 plus 6 is 15. So 15 is not greater than 15. 15 equals 15. So actually, this is not true. So this is an X. Is 9 plus 15 greater than 6? It sure is. Is 6 plus 15 greater than 9? Absolutely. But because one of these is not, then no triangle. All right, one more. Given angles measuring 26, 64, and 90 degrees, can you construct a triangle with those conditions? First question, does the sum of the measures of the interior angles equal 180 degrees? Well, 26 plus 64 plus 90 is indeed 180 degrees. Remember, it can't be greater than 180 degrees, and it can't be less than 180. It must be exactly 180. So now you say, how many different triangles could you actually create with these conditions? Well, consider this. You have three angles, and that's fine, but the sides can be different lengths, can't they? Well, they certainly can, because this can extend, and this can extend, and this can extend, and you can also enlarge the whole thing as long as the sides are in proportion to one another. So this side would be proportional to this side in length, which would be proportional to this side in length. And likewise, this would be proportional to this length, which would be proportional to this length. These would be similar triangles. And we'll don't want to leave this out, that this too would be, this length would be proportional to this length, which would be proportional to this length. So as long as those conditions are met, then you have similar triangles. You could have quite a few triangles that meet the condition of 26 degrees, 64 degrees, and 90 degrees. You're just changing the length of the sides, and they are in proportion to one another. That's important to remember. Okay, that ends this little brief video on having conditions set and trying to determine whether you can even make a triangle, and if so, how many. None, a whole bunch, or just one, like in the case of the isosceles triangle. Enjoy the activity.